Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is a database design concept, and the same chapter, that is a chapter number 8, that is a relational database design. That is what are the various relational database design, or how to design the relational databases. That is a relational database design. So let's start with the previous class session, what we have covered in the last class, and then move to the today's class topic, that is a continuation of the chapter number 8. In the last class we have started with the relation database design, that is how to represent or how to design the relation databases and how to represent them with the use of the year diagram, with the use of the year models. Then we have shown about the what are the features of a good relational design, that is what are the new features of a good relational designs. So there are the features of good relational design, that is what are the various features, or how we can say that it is a good relational design. So what are the various features? The main concern is that there is no duplication of data, that is there is no repeated data that is available. That is also discussed in this features, that is there is no duplicate data that is available. Now first one is, what is the design alternative, what is the schema, what is the, we can say, the logical design that is used for the designing the relational databases. So one of the design alternative is a larger schema, that is there are large number of tables, large number of columns, large number of rows that is available, that becomes, or that forms a relational database design. Suppose instead of having the schema like instructor and the department, we have the instructor department ID, name, salary, department name, building, and the budget. This represents the result of a natural join. When we join the data, when we flow the data, when we take the data in a efficient order. Then we have discussed about the building and the budget example, that is how the building and the budget are used in the day-to-day life, or in the, we can say, the database analysis. Then the next alternative that we will discuss is the smaller schema. So one is a larger schema, that is a larger database. We can say the larger table, larger column, larger tuple are used. Then there is a smaller schema, that is there will be a small schema that is also available, that is the data is divided into small tables, or that contains the number of columns and the number of cells or the rows that are typically small. So in our example, how we can know in our university what are the various methods, what are the various departments, each with the reside in a single building or having a small budget building. So this is a functional dependency, that the department name is depend on the budget. Now we can also define, or we can also combine the various schemas into one part, that is the various schemas into two schemas, or we can also decompose the employee schema into two parts. One contains the employee 1, that is a name, one contains the employee 2, that is a name, street, city, and the salary. So there are that the employee schema is divided into two parts, one is the employee 1, one is the employee 2. So this is the employee, and this is divided into two parts. One is the ID, one is the name, that is also the name, street, city, salary. So one is the employee 1 table, one is the employee 2 table. Now these two tables are joined with the natural join by we can that it can give the name, street, city, salary, and the ID. That is this duplicate data cannot be repeated, that is the name and the name cannot be deleted or cannot be repeated. So there are two types of decomposition that is available in this one that we have studied. One is a lossless or lossless. There is no loss of the data. There is no loss of the data. One is a lossy, in which some data are lost while decomposing, while splitting the data into multiple parts. Next is the atomic domain and the first normal form. Now, we also discussed about the atomic domain and the first normal form that is available. So ER model allows entity set in the relationship set to have the attributes that have some degree of structure that is also available. So we can also provide some degree of structure that is also available in this one. So there are multiple degrees that is also available in the relational database that we have discussed. So one is the atomic domains, that is a domain in which the atomic numbers, means the atomic values are used. So that is a domain, that is a group. So a domain is said to be atomic if the elements of its domain are considered to be the indivisible unit. So if there is an indivisible or indivisible unit that is not divisible by anyone, that is known as the domain is said to be atomic. If all the elements are the considered as the indivisible units. we say that a relation schema R is in first normal form, that is in a 1NF, if the domain of all the attributes of R are atomic. So if the domain of all the attribute that is available is atomic, so we can say that that is in the first normal form. A set of names is an example of non-atomic value. So whatever the names, whatever the content that is given, that is example of the non-atomic value. For example, if the schema that is available of a relation employee included an attribute children, whose domain name attributes or elements are set of names, schemas that will not be in the first normal form. Then we have discussed how to decompose using the functional dependency, that is what are the various functional dependencies, and how to decompose, how to break the main table or the employee table into multiple parts using the functional dependencies, that is how one table is related or depend on the another table, that is the functional dependencies. This methodology is depend on the keys and the function dependency. So in discussing the algorithm for the relational database design, we shall need to talk about the arbitrary relationship and their schemas. So in general, we use the Greek words for the set of the attributes, for example, alpha, beta, and the gamma. We have discussed about this one. Then there is a super key that is also available, that is a alpha, then there is a gamma. Then we have discussed about the keys and the functional dependencies, that is what are the various keys that is available and what are the various functional dependencies that is available in the keys. So students and the instructor are uniquely identified either the or by their ID. So if I'm using the ID, that the student and the instructor that is available, that are uniquely identified by their ID. Then every student has a unique name, that every student and the instructor have a unique name. Every instructor and the student is associated with only one department. Every department or each department has only one value for its budget and only one associated building. So an instance of a relation that satisfies all such real constraints is known as the legal instance of a relation. Some of the most commonly used types are the real words constraint that is also available, that is a super key, and the we can say the super key, one is a normal key that is available. So this is also we have discussed what is the meaning of travel, what is the meaning of bilingual, what is the meaning of various normal form, that is the closer, that is the next normal form that we have studied about the BCNF, that is the boy code or boy code normal form. So one of the desirable normal forms that we can obtain is the boy code normal form, that is the BCNF. It eliminates all the redundancies. So every redundancies we can say the eliminates or removed by using the or in the BCNF, that is the boy code normal form, that can be discovered based on the function dependency. So BCNF is nothing but we can say that it is in this for normal form there is a data that is removed, so it eliminates all the redundancy that can be discovered on the function dependency. So this is alpha beta, that is a travel functional dependency, that is a beta is contained in the alpha, and alpha is a super key for a schema R. So database design is in BCNF. Each member of the set of a relation schema that constitutes the design is in BCNF. So when we say that the database design is in BCNF, so every member of the set of the relation schemas, so every member that is available that constitutes the design is in BCNF. Now this is an example, that is a example of the relation schema that is not in the BCNF. So there is the instructor department, there is ID, the name, salary, department name, building, and the budget. The functional dependency department name, budget holds on the instructor department, but the department name is not a super key. So this is not a super key, but we can apply the ID name, that the department name, and the salary. Then BCNF and the dependency preservation, that is what is the BCNF and what are the various dependency preservation that is available on the BCNF. That is the primary key constraint, functional dependency that is also available, check constraints, and the assertion and the trigger. So these are the various parts that is also available in the BCNF. That is what are the various functional dependencies, what are the various check constraints, assertions, and the triggers. So this is the instructor, this is a student that is available. This contains three parts: ID, name, and the salary. Student also contains three parts: ID, name, and the total credit. And this is a department advisor that is also belongs to the department table. That is the department name, building, and the budget. Now, then we will discuss about the third normal form, that is what is the meaning of third normal form. So when we say about the relation schema that is available in the third form, normal form with respect to the set F of the functional dependency, if for all functional dependency in FF is alpha arrow B or alpha beta, that is also available. That is the third normal form. That is every we can say the duplication can also be removed, and the one table or the functional dependency means one of the table is depend on the functional dependencies. Then next is the higher normal form. That is what is the higher normal form that we have discussed. So one is a BCNF, one is a 1NF, one is a 2NF, one is a third NF. Then the next one is a higher normal form that is also available. So using functional dependencies to decompose schemas that may not be sufficient to avoid the unnecessary repetition of information in certain cases. So consider a slight variation in the instructor entity set definition in which we record with each instructor a set of the children's name and the set of the phone number that is available. Therefore, the phone number and the child number would be multi-valued attributes, and the following are the rules for the generating the schema. So this is the ID and the child name and ID and the phone number. If we were to combine these schemas, then we get ID, child name, phone number. So these are the three entities that is available, that is in the form of the a higher normal form. Then functional dependency theory, that is the next topic, that is today's topic. That is how what are the various theories that is available on the functional dependency theory. So let's start with the today's session, that is the next topic, that is the functional dependencies theories that is available in this chapter. So this is the functional dependency theory, that what are the various theories that is available on the functional dependency. The first part is closure of a set of the functional dependency, that is how to find the closure or how to make the closure of a set of the functional dependency that is available. So how different elements, how different relations are depending on each other, that is the functional dependencies. That is logically implied by the functional dependency that is also available. So one is the closure, that is of the F, that is denoted. One is the axioms or the rules of the inference that provide a simple technique or the simpler technique for reasoning about functional dependency. That is what are the various functional dependencies that is available, that is the axioms. Then collection of the rules is known as the Armstrong axioms in honor of the person who first proposed it. So what are the various rules that is available? One is the reflexivity rule, one is the augmentation rule, one is the transitivity rule. So there are three rules that is available: reflexivity or reflexivity, and the augmentation and the transitivity rule. So these are the three rules of the theories. Then there is a union rule, decomposition rule, and the pseudo-transitivity. The next is the closure of attribute states, that is what are the attribute states and how to find the closure that is functionally dependent or not. Then canonical cover is also used in this one, that is how to use the canonical cover, or when we say that there is a functional dependency, that means there is a cover, that is there is a canonical cover that avoid or that we can say that the protect the database with the functional dependencies. Then what is a lossless decomposition? That is if there is no loss of information by replacing the two relation schema, that is the R1, R1, R2, R2, that is known as the lossless decomposition. That is there is no loss of data, that is a lossless decomposition. Then there is a dependency preservation, that is how to preserve the dependency controls. Then next is the algorithm for decomposition, that is a today's topic basically, that is what are the various algorithms that is available for the decomposition. So let's start with the algorithm for the decomposition. Now the next is what are the various algorithms that is used for the decompositions. This says real world database schemas or are much larger than the example that fit into the pages of the book. So when we talk about the real world database schema, suppose if I'm talking about the bank, when I go to the bank and there is a decomposition part, and there is a, we can say, the database schema that is available, that is there a detail of the student, detail of the customer that is available, that is a database schema. That is a real world schema, that is a real world database schema that is available, that is how to make the real world database schema that is much larger than the example that fit into the pages of a book. For this reason, we need the algorithm for the generation of design that are in appropriate normal form. So for this reason, we have to need the algorithm that is used, or that is the best method, or that is the generation of the design that are in the appropriate normal form. In this section, we present the algorithm for the BCNF and the 3NF. So there are various algorithms that is available for the BCNF, that is a void code normal form and the third normal form. So first one is BCNF decomposition, that is what are the various algorithms that is used for the dividing into or decomposing into the BCNF, that is a void code normal form. So the definition of BCNF can be used directly to test if the relation is in BCNF or not. However, computation of F plus can be a tedious task. We first describe below a simplified test for verifying the relation is in BCNF. So first of all, we have to define the relationship, whether the test is, or whether the relation is in BCNF or not. If the relation is not in the BCNF, it can be decomposed to create the relationship that are in BCNF. So if the table is not in the BCNF, so then we distribute, or then we decompose the relation or relations into the different BCNF. Then in this section, we also define the algorithm that creates a lossless decomposition of the relation, such as the decomposition is in BCNF. So this is the lossless decomposition, that is the data is not lost in the decomposition of the relation. The first point is testing of the BCNF, or testing for BCNF. So first of all, whether test whether the relation, whether the table is in BCNF or not. So testing of a relation schema R to see if it is satisfied BCNF can be simplified in some of the cases. So whether it is simplified in some of the cases or not, that is also the one of the tests that is available for the BCNF. So this is first point says what are the various cases in which the BCNF is satisfied. To check if a non-trivial dependency, that is the alpha beta, can causes the violation of the BCNF, compute alpha plus and verify that it concludes all the attributes of R, that is it is a super key of R. So this is a super key of R, that is a super key of R. To check if a relation schema R is in BCNF, if it suffices to check only the dependency in the given set F for violation of BCNF, rather than check all the dependencies in the F plus. So whether to check dependencies in the F plus or not. We can show that if none of the dependencies in the F causes a violation of the BCNF, then none of the dependencies in the F plus will cause a violation of BCNF either. Unfortunately, the latter procedure does not work when the relation is decomposed. That is, it does not suffix to use the F when we test a relation Ri is in the decomposition of R for the violation of BCNF. For example, consider the relation schema, that is the R, this is the R, and there are multiple parts, that is the A, B, C, D, E with the functional dependencies. F containing A belongs to B and the BC belongs to D. Suppose this were decomposed into R1 and the R2, that is the AB, AC, DE. Now, neither of the dependencies in the F contains only attributes from the ACDE. So we might be misled into the thinking R2 satisfied BCNF. So this is a scenario that says there are four relationships, there are four attributes in the relationship, that is the A, B, C, D, E, and there is the R1 and the R2, that is a suppose this whole relation, that is the ABC, divided into two parts. One is the AB and one is the ACDE. What is the common in between? That is the A. So this is a primary key that is a common in between two relations, that is the R1 and the R2. Now neither of the dependencies in the F contains only attributes from the ACDE. So we might be misled into the thinking R2 satisfied BCNF. So there is a dependency, that is the AC arrow D in the F plus. Therefore, we may need a dependency that is in the F plus but not in the F to show that decomposed relation is in the not in the BCNF. So what is the alternative test that is easier for computing purpose? That is every dependency in the F plus. To check if a relation Ri is in the decomposition of R is in BCNF or not, so we check the relation, we check the rule that is used. So for every subset alpha of attributes in Ri, check that A plus either includes no attributes of Ri minus alpha or includes all attributes of Ri. So this is the result that is given. That is R, then done, then F plus, then while not done, do. What is the do relation that is doing? Then next is the BCNF decomposition algorithm. Next part is what are the various decomposition algorithms that is used, that is the BCNF decomposition algorithm. Now we are now able to state a general method to decompose the relation schema so as to satisfy the BCNF. What are the general method that is used? That is the decomposition part that the algorithm generates is or not in the a BCNF, but is also a lossless decomposition. So the BCNF decomposition algorithm takes this time exponential in the size of the initial schema. Since the algorithm for checking if a relation in the decomposition satisfies BCNF can take exponential time. That is the BCNF that takes the exponential time, that is also available for the over normalized form, that is decomposing a relation unnecessary. So suppose we have database design using the class schema below. This is the class, this is the course ID, title, department name, credit, section ID, semester, year, building. The set of the functional dependency that we requires to hold on the class are. So what are the various what are the various set of the functional dependency that is used in the relational, or that is used in the functional dependency. So what are the various classes that is used? So first one is a course ID, that is arrow, title, department name, credits. Then there is a building, then a room number, capacity, then there is a course ID, section ID, semester, year. Then this also belongs to the building, room number, time slot ID. So a candidate key for this schema is, what are the various candidate keys? That is a section ID, course ID, semester, and the year. Now what is the functional dependency? That is the course IDs depend on the title, department name, and the credits. Now next is the how to decompose the third normal form, or the third normal form that is decomposed into various parts. That is the 3NF decomposition. So this is the algorithm that is also used for finding a dependency preserving lossless decomposition into 3NF. The set of dependencies that is used in the algorithm is a canonical cover for the F. Note that the algorithm that is used considers the set of the schema that is available that start with a 1, then 2, then till I. Initially I equals to 0. On this case, the set is empty. Now let us apply the algorithm to the section that when we show that the department advisor SID IID department name is in 3NF even though it is not in the BCNF. So what are the various algorithm that is used? That is the ID name is the department name, then ID name or SID department name is ID. Now what are the various correctness of the 3NF algorithm? So what are the various forms that is available in the 3NF algorithms? The 3NF algorithm ensures the preservations of dependency by explicit building a schema for each dependency in canonical form. The algorithm that is used, or that is known as the 3NF synthesis algorithm, since it takes a set of dependencies and adds one schema at a time. So when we use the 3NF, so it uses, or it takes a set of the dependencies and adds the one schema at a time. That is, only one schema is added at a time. Now next is the comparison of the BCNF and the 3NF. So what is the comparison, or how to compare the BCNF and the 3NF? So of the two normal forms for the relational database schema, 3NF and the BCNF, there are more advantages of the 3NF in that we know that it is always possible to obtain 3NF design without sacrificing it. That is, without sacrificing it, we have to define the schema that is also available for the BCNF. So there are some disadvantages of 3NF also. That is, there are some, or we have to use, or we may have to use the null values to represent the meaningful relationship that is available. So there is the problem of the repetition of data. So what is the advantage of 3NF? That is, there is no loss of data. What are the limitations? There is a duplication of data, that is, the redundancy is maintained among the 3NF. Now, what are the various goals of the database design? So our goals of the database design with functional dependencies are, that is the BCNF, then losslessness, the dependency preservation. Since it is not possible to satisfy all three, we may be forced to choose between the BCNF and the dependency preservation with 3NF. Although testing functional dependencies may involve a join if the decomposition is not dependency preservation or preserving. Now next is decomposition using the multi-valued dependencies, or how to decompose using the, or how to maintain the decomposition using the multi-valued dependencies. So some relation schemas, even though they are in the BCNF, do not seem to be sufficient or sufficiently normalized, in the sense that they are still suffer from the problem of repetition of information. That is, they are normalized, that is, they are sufficiently normalized, that is, they are sufficiently take the form, or we can say that there is no duplication of data, that is a normalized or there is a normalized relation. Consider a variation of the university organization where the instructor may be associated with the multiple departments. So this is the example. There is an instructor, then ID, department name, street, and the city. This is divided into two parts, that is R1, that is ID and the name, then R2 relation to is the ID, department name, street and the city. Then to deal with the problem that is available, we must define a new constraint that is available, that is known as the multi-value dependency. So what are the problems that is used in the multi-value dependency, or that is used in the 3NF dependency or the 3NF decomposition? So that will be removed, that will be replaced by using the multi-valued, by using the constraint that is known as the multi-valued dependency. So as we did for the function dependency, we shall also use multi-value dependencies to define a normal form for the relation schemas. So this normal form is known as the force normal form, that is a 4NF, that is more restrictive than the BCNF. We shall see that every 4NF schema is not in the also in the BCNF, but there are BCNF schema that are not in the 4NF. So every 4NF schema, every 4NF, we can say the tables are is also in the BCNF that is available, but there are BCNF schema that are not in the 4NF that is also available, right? Then next is a multi-value dependency, that is what is the use of the constraint that is available, that is a multi-value dependency, that is more than values that depend on the each other, that is known as a multi-value dependency. So functional dependencies rule out certain tuples from being in a relation. That is, if A arrow B, then we cannot have two tuples with the same A value but different B values. Multi-value dependencies, on the other hand, do not rule the existence of the certain tuples. Instead, they require that the other tuples of the certain form may be present in the relation. For this reason, functional dependencies, sometimes also referred as the equality generating dependencies, and the multi-value dependencies are known as the tuple generated or generating dependencies. So functional dependency is sometimes known as the equality generating, and the multi-value dependency is sometimes known as the tuple generating dependencies. So one is the equality generating, one is the tuple generating dependencies. Let R be a relation schema, and let A is contained in the R, and the alpha is contained in the R, and the beta is contained in the R. So the multi-value dependency that is available, that is the alpha arrow arrow B. So there is the alpha that is also contained in the B, that also holds on R if any legal instance of R for all pairs of tuples T1 and the T2 in R, so that T1 alpha equals to T2 alpha. This is we can say the tabular representation, how to represent the T or the alpha arrow arrow beta. So as with the functional dependencies that is available, we must use a multiple or multi-value dependency in two ways. So there are two ways for the multi-value dependencies. The first one is to test the relation to determine whether they are legal relation under the given set of the functional dependency and the multi-value dependencies or not. So to test the relations, we can say the relations or table that is used or that is able to determine whether they are legal tables based on the set of the functional and the multi-value dependencies. That is, what are the multi-value dependencies and what are the functional table that is used with the multi-value dependencies. So to test determine they are legal under a set of this one, there is a ID. This is an example of redundancy in a relation on a BCNF schema. This is the ID, then there is a department name, street and the city. One is the ID, then what is the department name, then there is a street, then there is a city. This is also ID, that is the illegal R2 relationship. This is the legal and this is the illegal R2 relationship. To specify constraint on the set of the legal relations, we shall therefore concern with only those relations that satisfied with on a given or that satisfies on a given set of the functional and the non-functional or the multi-value dependency. So whenever I want to apply the constraint that is available on the legal relation, we can apply the relations, we can use the relation, we can satisfy the relation schemas with the multi-value dependencies. Note that if a relation R fails to satisfy a given multi-value dependency, we can construct a relation R1 R dash that also satisfied the multi-value dependency by adding the tuples to the R. Now let D denote a set of the functional and the multi-valued dependency. The closure of the D plus of the D is a set of all functional and the non-multi-value dependencies that is logically implied by the D. So what is the closure? That is the D plus is also fine for the closure of the functional as well as the multi-value dependencies. So from the definition of multi-value dependencies, we can derive the following rules for alpha and the beta that belongs to R. So alpha is we can say the denoted with the beta, and the alpha is arrow arrow b. In other words, every functional dependency is also a multi-value dependency. And next is if alpha arrow arrow b, then alpha arrow b r and minus alpha minus beta. Then the next normal form is the fourth normal form that is also available. Now consider our same example of the BCNF, that is the R2, ID, department name, street, city. So these are the four fields. We can say that these are the four attributes that is available in the R2 relation. What are the four fields? What are the four attributes? That is ID, then department name, city and the or street and the city, in which the multi-value dependency ID arrow street city holds. That is, there will be a multiple value that is also available, that is a multi-value dependency that is available with the R1 and the R2. So we saw in the opening figures, we saw in the opening paragraphs of the section 8.6 that although this relationship is in BCNF, that is also available, the design is not ideal, that is not basic design that is used. So we can use the given multi-value dependency to improve the database design by decomposing the schema into fourth normal form decomposition. Now, a relation schema or the relation or the table is said to be in the fourth normal form with respect to the section or with respect to the set D of the functional and the multi-value dependencies if all multi-value dependency in D plus of the form alpha arrow arrow B, where alpha contained in the R, beta also contained in the relation R. At least one of the following holds. Either alpha arrow arrow B is a trivial multi-valued dependency, or either alpha is a super key of the relation, or alpha is a super key for the R. So database design is in 4NF if each member of the set of the relation schema that constitutes the design is in 4NF. So when we say that it is in the 4NF, that every member of the relation schema that constitutes the design is in 4NF. Note that the definition of 4NF differ from the definition of the BCNF. Is only the use of the multi-value dependence. So what is the difference, or what is the, we can say, the definition of BCNF, that is on the use of the multi-value dependency. Now let R be a relation schema and let R1 R1, R2 R2, Rn Rn be a decomposition of the R. So to check whether the restriction is available or not, that is done by using the restriction by using the only attribute that is available with the relation R. So the restriction of D to Ri is a set Di consisting of all multi-value or all functional dependencies in D plus that includes only attributes of Ri. All multi-value dependency of the form, that is alpha, then arrow arrow B intersection Ri, where the A also contained in the Ri and the A alpha also belongs to the B, that is arrow arrow in the D plus. The next is the 4NF decomposition, that is how to distribute the 4NF decomposition. So the analogy, or there is a relationship between the 4NF and the BCNF applies to the algorithm for decomposing the schema into 4NF. That is, what is the relationship between the, or what is the, we can say, the relationship that is available between the 4NF and the BCNF that forms the algorithm, or that forms as the basis of the algorithm for decomposing a schema into the 4NF. So figure 8.16 shows the 4NF decomposition algorithm. It is identical to the BCNF decomposition algorithm of the figure 8.11, except that it uses multi-value dependencies and uses the restriction of D plus to the Ri. So what is the basic decomposition, or what is the basic, we can say, the situation that is available, that it uses the multi-value dependencies and uses the restriction of D plus to the Ri. Now if we apply the algorithm of figure 8.16 to ID, department name, street, city, then we find the ID arrow arrow department name, that is a multi-value dependencies. So following the algorithm, we replace it by the two schemas, that is the R21 ID department name, then R22 ID street and the city. This pair of schemas, which is in the 4NF, eliminate the redundancy that we encountered easily or earlier. So this pair that is available, that eliminates the redundancy, that eliminates the duplicate value that is encountered earlier. As was the case when we were dealing solely with the functional dependencies, we are interested in the decomposition that are lossless and preserve the dependency. So there are two methods, there are two, we can say, the criteria that is used while decomposing the methods. What are the two criteria? The first criteria is that it eliminates the redundancy, that is it eliminates the duplication parts, there is no loss of the data, and there is a preservation of the dependency that is available. So this is the 4NF decomposition that is used. So this is the fact that is also available for the multi-value dependencies and the lossless algorithm, that is a lossless decomposition. So that is, first of all, the result equals to R, then done equals to 4, then compute the D plus, then use a while loop. As we have studied in the C programming, there is a while loop. So first of all, there is a condition. While the condition is satisfied, then the operation is performed. And while using the while loop, then there is a do operation, that is if, then there is a if operation, that is the if statement that is used, there is a else statement that is used. Now next is the more normal forms that is also available, that is the more normal forms also available. So for normal form is by no means the ultimate normal form. So as we saw earlier, multi-value dependencies helps us to understand, eliminate some form of repetition of data that can be understood in terms of the functional dependencies. So the main target of the normal form is to remove the duplication, that is remove the redundancy among the database. So there are two types of constraint that is available. One is the joint dependencies that generalize the multi-value dependencies and lead to another normal form known as the project join normal form, that is PJNF, that is the fifth normal form in some book. So some books says that the fifth normal form is PJNF, that is the project join normal form, but some says it is a fifth normal form, some says it is a PJNF. So there is a class of even more general constraint that leads to a normal form, that is a domain key normal form. So that is a DKNF. One is a PJNF, that is a project join. One is a DK, that is a domain key normal form. A practical problem that is used with the generalized constraint is that they are not only hard to reason with, but there is also no set of sound and complete inference rule for reasoning about the constraints. Hence the PJNF and the DKNF, that is a project join normal form and the domain key normal form, are used quite rarely. It is from the discussion of the normal form is second normal form, that is the historical interest only. Now next is the database design process. So what are the various design processes that is available in the database? So let's take a break, then move to this topic, that is what are the various processes that is available for the database design. So let's take a break right now. So come back from the break. Now let's start session again. So let's start with the next topic, that is the database design process, or what is the process that is used for the database design. So far we have looked at the detailed issue that is available with the database design. Now about the normal form and the normalization. In this case, and in this section, we studied how normalization fits into the overall design structure, or what is the use of the normalization, what is the use of the normalized data, that is what are the various processes that is used for the designing part. Earlier in the chapter, starting in the section 8.3, we assume that the relation schema R is given and proceeds to the normal form. So the relation is given and we need to process for the normal forms. There are several ways in which we can come up with the schema, that is how to design the database, what are the various schema that is used that we can proceed to the normalize it. So what are the various ways that we come up with the normalized or relation R? The first point says R could have been generated in converting an ER diagram to the set of the relation schema. So what are the various schemas, or what are the various ER diagram that is representing in the set of the relation schemas in set of the relation logical model that is available for the ER model. Now R could have been a single relation schemas containing all the attributes that are of interest. The normalization process that breaks up R into the smaller schemas. Then R could be the result of the ad hoc design of the relations, and that we then test to verify whether it satisfies the desired normal form or not. So test whether it satisfies the normal form or not. Then in the rest of this section, we examine the implications of these approaches. We also examine particular issues that is used in the database design, including the normalization or denormalization for performances and examples of the bad design that are not detected by the normalization. The first point is ER model and the normalization. So how to use the ER model, or what is the ER model, and what is normalization, that is how to sort the data, or how to make the database, or how to make the table as a normalizer. That means reducing or removing the duplicate data, that is removing the redundancy or duplicate data among the database or among the tables. So when we define an ER diagram carefully, identify all the entities correctly. So when we identify the ER models, ER diagrams, so identify all the entities, what are the various entities that is available in the ER model. Correctly, the relation schemas generated from the ER model should not be further normalized. However, there can be a functional dependencies between the attributes of an entity. For example, suppose an instructor entity set has an attribute department name and the department address, and there is a functional dependency that is the department name and the department. So we would then need to normalize the relation that is generated from the instructor. And most of the example that is available or that is arise out of the poor ER design, that is we have designed the ER model correctly, we will create a department entity set with an attribute department address, department name and the department quantity that involves the various quantities that is available with the revised we can say the databases or the updated databases. Functional dependency can also or can help to detect the poor ER design. So whenever we use a functional dependencies, that what type of functional dependencies is available in the database, that is a very good method. That is one of the important aspects to detect the poor ER diagrams or the poor ER design. So if the generated relation schemas are not in the desired normal form, the problem can be fixed in the ER diagram. That is, normalization can be done formally as a part of the data modeling. Alternatively, normalization can be left to the designer intuition and during the ER modeling. So what are the various issues that is arising from the functional dependencies? That is a many-to-many relationship set and then multi-valued attribute of an entity set. So for a many-to-many relationship set, each related entity has its own schema and there is an additional schema for the relationship set. So that contains a multiple attribute that contain the entity set, that is a phone number, that is a instructors. Now, next is the naming of the attributes and the relationships. So what are the various names of the attributes and what are the various relationships of the attributes? So a desirable feature of a database design is a unique role assumption. So there is a unique role assumption that is available. That means every attribute or each attribute's name has a unique meaning in the database. This prevents us from using the same attribute to mean different things in the different schemas. For example, we might otherwise consider using the attributes number for the phone number in the instructor schema and for room number in the classroom schema. So the join of a relation on the schema instructor with one on the classroom is a meaningless, that is used. So while it is a good idea to keep names for incompatible attribute distinct, if we keep the relation as the same meaning, that is a good idea for the attribute names. So this is a relation, that is how to use. So whenever we use the select star, that means all the fields are selected. So in a large database schema, relationship sets are often named via concatenation of the names of the entity sets. So when we combine the multiple schemas or when we combine the multiple relationship, that is combined via concatenation of the names of the related entity sets, perhaps with the hyphen or the underscore. So there is no need of the underscore, there is no need of the hyphen, but we use the concatenation to concatenate the various relation, various schemas. So we have used a few such names, for example, instructor or instructor section and the student section. We use the names teaches and the takes instead of using the long concatenated names. This was acceptable since it is not hard for you to remember the associated entity for few relationship sets. We cannot always create relationship set names by simply concatenation. So there is no way to create the relationship set by using the concatenation. For example, a manager or the work for relationship between employees would not make much sense if we call it involve employee and the employee relationship. Now, denormalization for performance. So there are some conditions in which we have to denormalize the database, denormalize the relation schemas for the performances purposes. So occasionally database designers choose a schema that has a redundant information. So in an occasional part they are reducing or they are choosing the redundant information. That is, it is not normalized. They use the redundancy to improve performance for specific implication or application. The penalty that is paid for not using a normalized schema is the extra work to keep the redundant data constant. So the process of taking a normalized form and making it normalized or non-normalized, that is known as the denormalized. So whenever we take the normalized schema and whenever we make it as a non-normalized form, that is known as the denormalization. And designer use it to tune performances of system to support time critical operations. So a better alternative that is used by many or any database system that is used the normalized schema that is used for the join of the course and the prerequisite as a materialized view. Now next is the other design views, that is other design issues that is available with the database schema. So there are some aspects of database design that are not addressed by the normalization that can lead to the bad database design. So the relationship or the representation such as those in the department year relation with one column for each value of an attribute are known as the cross tabs. So there is a concept that is known as the cross tabs, that is for one column there is an attribute for there is a value for an attribute that is known as the cross tab, that are widely used in the spreadsheets and the reports and data analysis tool. Now next is modeling temporal data, that is what are the various models that is available for the model or for the temporal data. That is how to model the temporal data, or what is the main role of the temporal data, or what is the usage of the temporal data. So suppose we retain the data in our university organization showing not only the address of each instructor but also the formal addresses of which the university is aware. So we may then ask queries such as find all the instructors who lived in the Princeton in 1981. In this case we have to address, or we have multiple address for instructors. Each address has an associated start and the end date, indicating when the address was instructor was resident at that address. So a special value for the from the end key, that is a null, or the value that is in the future, that is 9991231, can be used to indicate that the instructor is still resident at that address. In these cases, in general, temporal data are valid, or are the data that have an associated time interval during which they are valid. So temporal data means the data that has a associated or that have a fixed time interval, fixed gap that is used during which they are valid. So there is a time interval, that is a time, that is a time gap or time scenario by which they are equal, or by which they are valid. We use the term snapshot of data to mean the value of the data at a particular point of time. So we use the term that is snapshot, that means usage of the data at particular point of time, that is for the timing they are valid. So that is known as a snapshot of the data. So the snapshot of a course data gives the value of all attributes of the title and the departments. Now modeling the temporal data is a very challenging problem for the various reasons. For example, suppose we have an instructor entity set with which we wish to associate a time varying address. To add the temporal information, we would then have to create a multi-valued attribute, each of whose values is a composite value. So whenever I want to add the temporal information, we use the multi-valued attribute by which or each of whose values is a composite value containing an address and the time interval. When we track the data values across the time, functional dependencies that we assume to hold, such as ID, street, city, that may no longer hold. Functional dependencies that can hold a particular or that can hold at a particular point in time are known as the temporal functional dependencies. So the functional dependency that is available for the time being, that is available for a particular point of time, that is known as the temporal functional dependency. Formally it is denoted by this one. Now that is we can say the temporal dependencies, or the how to model the temporal data. Now next is a summary, that is we have finished with the chapter. Now this is a summary of chapter number 8. So first of all, we showed pitfall in the database design and how to systematically design a database schema that avoids the pitfall. So there are some pitfalls, there are some loopholes that is available in the database design, and how systematically design a database schema that avoids the pitfalls. The pitfalls that is included repeated information and inability to represent some information. Next point says we showed the development of a relational database design from an ER design when schemas may be combined safely and when a schema should be decomposed. All valid decompositions must be lossless. Every decomposition that is used, that must be a lossless decomposition. We described the assumption of atomic domains and the first normal form. We introduce the concept of functional dependencies and use this to present two normal forms, that is the boycott normal form and the third normal form. If the decomposition is dependency preserving given a database updates, all the functional dependency can be verifiable from the individual relations without computing a join of the relations in the decomposition. Next point says, we showed how to reason with the functional dependency. We place special emphasis on what dependencies are logically implied by a set of the dependencies. Next, we also define some algorithms for the decomposing the relation into the BCNF. These are the relations that for which there is no dependency preserving BCNF decomposition. Then we use the canonical covers to decompose the relation into the 3NF. So whenever I want to decompose into the 3NF, we also provide the canonical cover to decompose the relation into the BCNF. That is a small relaxation of the or the small category of the BCNF condition. Then we also presented the notion of the multi-value dependencies. We specify constraints that cannot be specified using the functional dependencies alone. And there are multiple other normal forms also available, that is a PJNF, that is a project join normal form, and the next is domain key normal form, that also used for the functional dependencies alone. So we defined fourth normal form with the multi-value dependencies. Now other normal forms such as the PJNF and the DKNF also eliminates more subtle forms of the redundancy. However, these are hard to work with and rarely used. Appendix C gives the details on these normal forms. So when we review the issues in this chapter, note that the reason we could define are the regular approaches to a relational database design that is used as the mathematical formation. That is one of the primary advantages of the relational model compared with the other model that we have studied. Now, what are the various review terms that is used in this chapter? These are the various review terms. So these are the various review terms that is available in this chapter. That is review terms. Then there are practice questions, that is questions on this chapter, that is relational database design chapters. So these are the various questions. What are the various functional dependencies and how to form that, and these are again the question that is used on this one. Now next chapter is chapter number 9, that is the application design and the development. That is how to design the application, and what are the various, we can say, the designs, what are the various development phases that is available in this one. This is something related to the networking part, that is what is URL, how to design them. Very interesting topic. So this I'm not going to start right now. Let's finish this class over here only, and then move to chapter number 9 in the Monday's class, that is in the 20th of class, that is in the Monday's class. So this chapter I'm taking in the Monday's class, or I will take in the Monday's class. Right. So that's all for today's session. Thank you so much everyone for listening me. Now if there is any doubts, any confusions, you can ask the doubts from me. And if there is any clarification, you can ask the doubts, or you can ask the clarification from me. Right. So that's all for today's session. Thank you so much everyone listening me. Bye bye.